Okay, so our new unit is about exponential functions. We're going to start with talking about exponent's law first, okay? Because exponent's law is going to help us simplify, right? It helps us simplify the exponents. So an exponent law, basically, we are going to start with a multiplication law. So if you look at what I have here, so for us to be able to do the multiplication law, first thing we have the same base, okay? So your base has to be the same, and then your exponent doesn't matter what it is. So your exponent is a number, or it could be a letter, or it could be anything. Now, what does it mean when I have a to the power of 4 times a to the power of 5? Excuse me. So a times a times a times a 4 times, yeah? And then a times a times a 5 times, right? So that's right. So I have basically, instead of a to the power of 4, I can write it as a times a times a times a, right? So I have the a to the power of, that a to the power of 4 is a times a times a times a 4 times. Good. That I have times, right? So that times belong to this multiplication. And then I have a to the power of 5. So a times a times a times a, right? So altogether, how many a's do I have multiplied together? 9 a's, right? So it's a to the power of 9. All right? So let's do the second one. So this is called the expanded form. The second form is called the expanded form. So let's look at the second one. So I have a times a, and then times a times a times a times a. So how many a's do I have multiplied together? 6. So that's a to the power of 6. How about a to the power of 5 times a? It will be 6 too, because I have a times a times a times a, and then multiplied by another a, so that's a to the power of 6. And then a to the power of 6 times a to the power of 2, that's a times a times a times a. So that's 5, 6 a's, and then times a times a. So altogether I have 8 a multiplied together. Then for the next one, I have a times a times a times a, and then I have 3 a's. So that's altogether a to the power of 7. Can you find a relation between the final answer, so the expression as a single power, and the multiplication? So can you find a relation between the exponents right here and what we started with this? That's right. So whenever I'm multiplying two terms, if they have the same base, right? In this case, I have the same base. I have a and a, yes? What I do is I add the exponent to get my answer, okay? So I didn't have to write it in expanded form. I could have just went a to the power of 5 times a to the power of 4. That's 4 plus 5 is 9. So that's a to the power of 9. Okay? A to the power of 2 times a to the power of 4, it's a to the power of 6. Because 4 plus 2 is 6. So basically, what I'm doing here, that's the same thing as doing a to the power of 4 plus 5. That's the same as a to the power of 2 plus 4. A to the power of 5 plus 1. You guys see the correlation here? Okay? So whenever I'm multiplying, if I have the same base, I keep the base and I add the exponent. So I keep the like base The like base doesn't change, it stays the same. So if I have, let's say, a to the power of n times a to the power of m, it becomes a n plus m. Are you guys okay with this? Okay, now if I have the division, okay, so again, to expand the division, so I have a to the power of 5 to the power of 4. So I have 5 a's multiplied together in the top, 5 a's multiplied together at the bottom, right? What happens is when I have division is I can simplify, right? So when I simplify, what do I end up with in this case? A to the power of 1, right? Which is a. All right. Now, same thing here. If I do a to the power of 4, so that's a times a times a times a divided by a times a. I have a squared, right? So I don't have to write all of this together. Can you guys find a correlation here? What do I do with the exponent if I have the same base? I subtract, right? So if you look here, this is going to be a4 because I have a times a times a times a times a, right, over a. So this is going to cancel. I'm going to be left with a4. In order for me to find that, so that basically what I'm doing here is I'm doing a, keep the base, and subtract the exponent. Yeah? Keep the base, subtract the exponent. 4 minus 2 is 2. If I do 5 minus 1, that's 4. All right, what would be the answer for the next one? 6 minus 2, so that's 4. Four minus 3, that's 1. Okay? So you guys see the relation here? All right, so if I have the same base, right, and I'm dividing them, I subtract the exponent. Are you guys okay with that? So, again, the rule would be keep the same base or the like base and subtract the exponent. Again, this is important that you guys realize that you must have the same base. If you don't have the same base, this is not going to work. You can't use it. Are we good with that? Excellent. All right, so we're going to move on to the next law, which is the power to the power. So if I have a to the power of 4 and then to the power of 5, So that's the same thing as saying it's a to the power of 4 times a to the power of 4 times a to the power of 4 times a to the power of 4 and then times another a to the power of 4, right? So basically that base, which is a to the power of 4, is multiplied by itself 5 times. Are you guys okay with that? Right? Because I have this to the power of 5. And then if you add all of these 4s, because we remember that if I have the same base and I have multiplication, what do I do with the exponent? We just learned that. I add them. So if I add 4 plus 4 plus 4 plus 4 plus 4, that gives me 20, right? But what can I do to instead of me like expanding this and writing it so many times, what can I do to simplify this when I have power to the power? Multiply the exponent, that's right. So if you look at this, this is actually 4 times 5. Okay, so I can do this a couple more times. So let's look at this. Does that work? A2 times A2 times A2. A2 times A2 times A2, so that's 2 plus 2 plus 2, that's 6, so A6. But at the same time, if I actually do 2 times 3, what does that give me? 6, right? If I add these 3 up, that's going to give me 6. If I multiply the 2 times 3, that's going to give me 6. A5 to the power of 2. If I'm going to expand, that's going to be a to the power of 5 times a to the power of 5. 5 plus 5 is 10. But at the same time, if I do 5 times 2, that's going to give me 10. Okay? So the rule says if you have power to the power, you multiply your exponent. Okay? So you keep the base, and you multiply the exponent. So what would the answer be for the next one? A to the power of 18. It's not 18, it's a to the power of 18. Okay, and then for the next one, it would be a to the power of 4 times 3, which is a to the power of 12. Okay, so the law says you're going to keep the base, and then you're going to multiply the exponent.